Okay, now we finally get to a plateau, somewhere where we can kind of leave behind that integral that defines the Laplace transform. And now we state the generalizations of some of the preceding examples in the prior videos by means of this theorem, theorem 7-2. Okay, and we will also refrain from placing restrictions on S. We merely say S is sufficiently restricted to guarantee the convergence of the appropriate Laplace transform. So I give you theorem 7-2, which is in A, B, C, D, E, F, G form. I know you can't see G yet. I'll move the paper up. But in general, so the Laplace of a constant is just 1 over s, and remember we can move the constant in front due to the linearity principle, and then you would, so if it was 2, you'd pull 2 out in front, and it'd be 2 times 1 over s, okay? So now if you have t to the n, you would simply push in where n is an integer, all right, positive integer, 1, 2, 3, okay, on and on. You would put a factorial on top with an s raised to an n plus 1 power in the denominator. Okay, if you had an exponential with an e to the raised to the at power, you put 1 over s minus a. Okay, uh, Laplace of a sine kt format, you would put the k on top and s squared plus k squared in the bottom. Okay, and if you have the cosine, okay, of kt, it'd be s over s squared plus k squared. And for hyperbolic sine, Laplace sinh kt, it's k over s minus k squared. And cosh would be kt is s over s squared minus k squared. Okay, so let's see a quick example of this. Example 7 here. I'm going to evaluate the sine, the Laplace of sine squared t. Okay, I would bring in this trig identity, which is the cosine of 2a equals 1 minus 2 sine squared a. Okay, so with this in place, uh, I I would put I would solve this trig identity for the this is an alpha. Okay, an alpha. So I would solve this trig identity using alpha as t here, and then I would get sine squared t equals 1 minus cosine 2a over 2. Okay, so putting this trig identity in this form, I would place it into the Laplace bracket, okay, and then I would go to my table. And so I would have the Laplace of 1/2 minus 1/2 Laplace of cosine 2t. Okay, so over here I have cosine 2t. So it'd be s over s squared plus 2 squared. See? S over s squared plus 2 squared times 1/2. You could, like I say, you could linearity, you could pull out the 1/2 minus 1/2 here, and same here. So you end up with, after some manipulation of putting these two denominators together, you end up with 2 over s times quantity s squared plus 4. Job done. Aren't we happy? Thank you. Have a good evening.